Hello, what is energy? Energy is the ability to do work or apply force to move an object. If we take the second definition, this is the definition of physics, is to apply force, that means I need a force, to move an object some distance, so times distance. Energy equal F times D, distance. Now if we think about this guy, he want to move this object from point A to point B. If this guy is strong, that means his force is high. If we multiply this force by the distance, then this is energy. If you want a feeling of it, it means like how much work he has to put in so he could do this mission. Now if I want to relate the energy concept to electrical engineering, like two circuits, then energy would be power times time. But first we have to define power. Definitely we'll talk about power in next videos, but here I'm going to give you a brief understanding. If we think of these three objects, I'm having here a fan, a hair dryer, and a dryer, a clothes dryer. Now if I ask you which one of those has the most power or uses the most power, then if you guys think of it, you guys think that this machine is the most expensive and it's the harder to start. This machine, which is fan, is the lower, and you are correct. This thing that you just felt is the power. Power is the watts on which each of these machine, how much electricity at some instant they use so they work. This is power. Power is as the unit watts. If we talk about the fan needs from 55 to 100 watts. The hair dryer 400 to 1800. This is higher. And then the dryer machine is from 1800 to 5000 watts. So the dryer machine maybe uses 3 times what the hair dryer use, and this machine uses maybe 50 times what the fan use. Okay, now let's move from the power concept to energy. The energy is actually how expensive those machines the time were used. So the time would affect the energy. Energy is what you pay in the electrical bill. Let's think of some companies, electricity companies. They charge for each 1 kilowatt hour, which is the unit of energy, they charge 10 cents. So if I take these 3 examples and let's work on the average power. The average power here is 75. If we use this machine for 2 hours, that means 75 times 2 is 150. And 150, if you want to convert it to kilowatt hour, you have to divide over 1000. Why? Because this is watt, this is hour, so you get watt hour, that's the unit, and then kilowatt hour, kilo means 1000, that means you have to divide over 1000, so it's 0.15 kilowatt hour. If we multiply this by the price of each those kilowatt hour, which is 10 cents, you get 1.5 cents or $0.015. So 1.5 cents, if you pay 1.5 cents, you can use this fan for 2 hours. Let's take this hair dryer. If we use it for 7.5 minutes, 7.5 minutes over 60 minutes to give you like the unit of hour, multiply it by the average of this power, which is 1200, then you get 150 watt hour. The same watt hour that you used for 2 hours to use the fan. So the same power you use for the same energy you use for 7.5 minute here, you use the fan for 2 hours. Now this 150, we already said you only pay 1.5 cents for 7.5 minutes for the hair dryer. Now the last example here, the dryer. The dryer, if we use it for 2 hours and on average the power here is 3500, then 3500 times 2 is 7000 watt hour. Divide over 1000 is 7 kilowatt hour. Now this 7 kilowatt hour, if we multiply it by 10 cents, you get 70 cents. So you pay here 70 cents to use the clothes dryer for 2 hours, while for 2 hours you pay here a cent and a half. Which more expensive is the fan. So the time would affect the energy, but the power is at each instant, at each minute, at each second, how much this machine uses. So this is the power. Okay, now last but not least, if we take this sketch, this is the sketch between power and time. The power is only one of those instants. So one instant is the power, right? The power is the watts that each machine uses to work at some instant. But if we take the entire interval, then we're talking about multiplying power times time, which is energy. Now just to for your information, anytime you multiply two variables, it means that you're taking the area underneath the curve, which is integration. So you can use this formula, which is the integration of the power. If he gives you the power as a variable, let's say t squared minus 1, then if you take the integration for the entire period from 0 to 2 hours, t squared minus 1, and then you do the integration, which is t cubed over 3 minus t from 0 to 2, and then you plug in, you get the energy. That's it for today. We will talk in next video about voltage, and we will use the energy concept to define voltage. See you.